All right. So let us talk about some math problems on DeltaMath. So I'm going to be looking at Tuesday's topics, determine intercepts from factored form. So let's look at the first problem. So this should connect back to a Desmos activity we did last week, and some lessons from last week or 2 weeks ago as well. So hopefully this is familiar, but if it's not, let's talk about a few things. So first of all, the directions. Determine the y-intercept of the following equation, and then we see x plus 2, parentheses, negative x minus 5, parentheses, equals y. Okay, so really quickly, let's talk about what we mean by some of these. So it says determine the y-intercept. So if we're thinking about a parabola, and I'll just make kind of like a generic, parabola shape. When we are talking about the y-intercept of the parabola, that's the part where it crosses the y-axis like that. Maybe it's the bottom of the parabola, maybe it's not. But the one thing we know for sure is that at this point, the x value is going to be 0. So this is like the x value is going to be 0. So when we talk about finding a y-intercept, not from a graph, but from an equation, this is code for plug in 0 for x. And like, this is such a recurring theme in algebra, where so many of our problems are all about knowing what number to plug in for x and all the different ways that people can say that. So this way is y-intercepts are when x is equal to 0. So let's do that. So we're going to take this equation over here, and it used to be x plus 2, parentheses, parentheses, negative x minus 5, parentheses, and equals y. It's a bit messy, but whatever. Okay, but like I said, the y-intercept means that I'm plugging in 0 for x. So 0, parentheses, plus 2, parentheses, 0, minus 5. And I know it says like negative x, but negative 0 is still just 0. Okay, and then we finish this math. 0 plus 2 is, of course, 2. 0 minus 5 is negative 5. And this is equal to y. And 2 times negative 5 is equal to negative 10. So that tells me that the y value of the y-intercept is negative 10. So I'll erase my question marks because I now know for sure this is at negative 10. And because it's the y-intercept, right, we started by saying x was definitely 0. We plugged it in. We can end by saying y is definitely negative 10 and figure out what answer matches that. Now, if I were doing this problem on like a test, I might have actually started by looking at some of these answers and noticing that at least 2, 3 of them don't make sense, right? The y-intercept should have an x value of 0, which means this answer is wrong because the x values are 2 and negative 5. Similarly, negative 2, negative 5, negative 10, none of these make any sense. These all make sense, and the correct answer we see is 0, negative 10. So that's the answer we got. So I'm going to click on it. And before I hit go, I'm going to clear the annotations because they're going to look weird if I don't. Submit. Yes. Green check mark. Feels good. Multiple choice. All right. Shall we look at one more? Let's look at one more. So this one says, determine the x-intercepts of the following equation. So I'm going to do my thought bubble again. So if I have a parabola like this, the x-intercepts are where the parabola crosses the x-axis, the horizontal axis. So that would be here and here. Now the thing about the x-intercepts is that these are both situations where the y value is 0. And we're trying to figure out the x value. So let's think ahead now that this is a multiple choice problem. So if I know that the y value has to be 0, then I know that this answer is no good, this answer is no good, and this answer is no good. So I have this answer, 3, 0, 3, 0, and -1, 0, or 3, 0, and 1, 0 as possibilities. Okay, so how do I do this? Well, I know that the y value has to be 0, and I think this is actually a topic that's going to make more sense on Thursday. So the lesson from Thursday is going to cover this a bit more clearly. But again, this was also a Desmos activity from before. But since this is multiple choice, let's start by plugging some numbers in. So we could say, is this answer correct? 3, 0. So remember, this is the x value and the y value, and we can test it by plugging it in. So let's do that. I plug in 3 for x, so this would be -3 plus 3. I plug in 3 for x, so this would be 3 plus 1. And I plug in 0 for y, and I'm testing, is this true? So -3 plus 3 is 0, parentheses, and 3 plus 1 is 4. But of course, 0 times 4 is just 0. So then we have 0 is equal to 0. And that's true. So this one might be the right answer. However, these answers also have 3 and 0. So we need to do one more step and test either this one, -1, 0, or test 1, 0. Do you guys have a preference? If I don't hear anything, I'm just going to do the 1, 0 test. Okay, 1, 0 test it is. So same idea. I'm going to plug in 1 for x and 0 for y. So this becomes -1 plus 3 and 1 plus 1 equals 0. So -1 plus 3 is 2. 1 plus 1 is 2. 2 times 2 does not equal 0. So I know that this answer does not work. Simple, right? So that doesn't tell us about this last option, which is what if -1 is x? The last one. And if this is going slowly, that's fine. There is a faster way to do this that you might have already noticed involving negative signs and switching. But this is kind of a slow and steady way to do it. Don't worry about your computer crashing. It's totally fine. I get it. So I'm going to plug in -1 for x. So this is weird because now it's like -1 plus 3. and -1 plus 1 is equal to 0. Negative negative is a positive, so this becomes like +1 plus 3, which is 4. And -1 plus +1 is 0. 4 times 0 is just 0. And so that actually works. So this is not a question mark anymore. This is a check mark, which means both of these points are the final answer. Now, what I mean by shortcuts, and I won't go into a lot of detail, but what I mean by shortcuts is you might notice some patterns between the 3 and the 3 and how that combined to make 0 for one of the answers. And then the -1 over here, the -1 combining with +1 to make 0 as well. So -1 and a +1 creating 0 as well. You're going to explore this more on Thursday, but for right now, I'm going to call that as my final answer because both of those numbers worked. And green check mark. And let me delete these annotations because they're kind of confusing now. And there we go. It looks like DeltaMath kind of gives you a different way to think about it. In some ways, it looks like what DeltaMath does is more traditional. Set y equal to 0, solve both equations for x. And like I said, you guys, if you're not sure what step 2 means, check out Thursday's work and check out the videos from Mr. Durkin on Thursday. And I think you'll get a lot more out of this DeltaMath assignment. Okay, so that's it. I hope that helped. As always, if there are any questions, let me know, and good luck.
Thank you.